Hi, I'm Bart. I'm sharing with you 11 tips regarding Snowflake Cortex AI. My goal is to make it easy for you to start with it, as I believe Cortex AI has a lot of potential and is easy and fun to work with. Also, if you use a free Snowflake account, it is for free, of course, within account limits. Enjoy! When I started with LLMs, there was Llama CPP. I was running this locally on my machine. It was difficult to manage that. Then I found out that there's Llama CPP with bindings for Python, so I was using this. And again, it was much easier, but still very challenging. Then Ollama. Ollama was very easy to use. You just had to install that, download the model, and run it. That's it. It was very straightforward and solved most of my issues that I had with Llama CPP. But the challenge that I had is amount of resources that I had on my laptop. I was not able to run bigger models there. And then I moved to Snowpark Container Services from Snowflake, which allows to run any Docker container. And even you can get different configurations and even with GPUs. So this one has 92 vCPUs and 4 times 80 gigs of RAM for your NVIDIA and almost 900 gigs of RAM memory for your CPU. And it was a game changer for me because I was able to run actually any model that was available at the time. And I even created a blog post regarding that. You can find it on Medium. But it was still related to hosting something on your own. And I just wanted to be able to work with my data and LLMs directly without having to take care for the whole infrastructure. And then Snowflake introduced a complete function that allows to run any of those models mentioned here at the bottom, like Gamma 7b or Llama, where I just can call the complete function and use it on the data in my tables. And this is really a game changer for me. I'm lazy, that's why I love that Snowflake offers task-specific functions, like classify text or extract answer or parse document and so on. My favorite ones are summarize, where you can just summarize the text or column in your database, and extract answer, which allows you to extract answer from the document. So how do they work? I've created a small workbook here with text from Battlestar Galactica Wikipedia page, where I'm calling the summarize function. And as a result, I'm getting summary of this whole web page. So instead of having very long text and having to read it on my own, I can have it summarized. And I can do this for all the documents, all the texts that I have in my database. I can also extract answer from the same document, and the question is, who is Adama? As a result, I get JSON document with score that you can use to evaluate quality of the answer. Instead of having JSON, you can extract this information also from it directly and have a string as an answer. Sometimes I want to have full control over what I'm getting from our model, so I'm using complete function. I'm just providing a model as a parameter and prompt or history with some options. I can pick any model that is hosted on Snowflake. And how does it work? Let's take a look again. Now I'm going to summarize, this is my prompt, summarize the following text in 2 sentences, and again, the whole text from Battlestar Galactica wiki page. And I'm using Llama 3.170b here. And it has created me a summary. Of course, I can do fine-tuning so that this part is not returned, but here we can see there's also a summary of that text. So far, I was showing just returning results based on one input. But when you look here, I have a table with actors and characters, and I can do the same, like summarize in no more than 10 words. Then providing a column from the table. I'm limiting results only to 10. And this time the information comes from Wikipedia regarding the acolyte. So this is the history column, this is the summary that was generated, and I can control very well what I want to show here. Snowflake is very inexpensive, and even on free account you can play with all those functions. But if you would like to check what the costs are, then just go to understanding compute costs, and there is a table, Snowflake service consumption table, And on page 11, you will have number of credits per 1 million tokens for each model that you have here. I've already mentioned that Snowflake offers a lot of models. You can see the function and model available here in the table. And also there's a region assigned to each of those. So not all models are available everywhere. So if you are working with your data in some specific region, make sure that you know what models are there. In case some model is not available in your region, you can always use cross-region inference. There's a parameter that you have to set. It's Cortex enabled cross-region. You can pick a few values of those, and I'm using always the one that allows me to run models from any region. Then Snowflake will route my queries to this particular region and models that are hosted there. I just can use models from any region directly, and it saves a lot of time, but you need to clarify with your organization if you are allowed to use such a parameter, because inference happens in different region than your data resides. Sometimes I want to have more control over how complete function behaves. And if you look on the syntax and signature of this function, you can provide it with some options. And let's take a look on arguments. First argument is model, then you have prompt or history, and then we have options. And in options you can provide temperature, top P, max tokens, and guard race. So if you want to have more randomness or more creativity in your answers, just set the parameters of temperature and you will get more control over the output that is generated. As one of the parameters, you can also provide the guard race true if you want to have the guard race enabled. So it allows you to better control harmfulness of the answers that you are getting from the LLM. So it's filtered out. If you have this enabled and the answer was harmful, you will get a message like that, response filtered by Cortex guard. And it is a built-in feature of complete function, so you don't have to implement it yourself. Cortex also allows you to use REST API. Through the REST API, you can call complete function. Model availability, just like using complete function from SQL. There are some usage quotas. It's worth to take a look on that. There's definition of the endpoint, description regarding authentication and authorization, example regarding how you can submit requests. Using this example, you can easily build into your command line pipeline a call to a REST endpoint, and you can pipe outputs from one command to your LLM and get its output and put it to input of another command. So, but if you are not a big friend of CURL and chaining commands in Unix, you can always use Python API. You just have to install the library and directly from Python call the functions that you need. In this example, we are calling complete. I was always wondering how to create such a model on my own, but it appears it requires a lot of resources. So I could use Snowpark Container Services for that, or just fine-tune a model that already exists. And in Snowflake, I can do it easily. We have to prepare the training data and test data or validation data, and we just call function Snowflake Cortex fine-tune. We create the new model. This is the name of our new model. This is the model that we fine-tune. And here we provide the training data. Here we provide validation data. And this will create my tuned model that you can easily use. And thanks to this approach, you can train smaller models to perform tasks of the bigger models. And thanks to this, save time and money. And everything is serverless. You don't have to take care for any infrastructure. You don't have to take care for anything but your training and validation data. I have never seen a simpler solution for this problem. I hope you liked my 11 tips to accelerate your work with LLMs in Snowflake Cortex. Feel free to comment and share ideas regarding topics you would like to learn more about. Of course, spread the word and happy coding!